Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at polynomial division. We will look at dividing a polynomial by a linear factor. So there are two methods I'm going to go through, long division and synthetic division. You can choose which you like best. So let's look at long division and do this question here. So it's essentially saying how many times does x minus 1 go into the polynomial x cubed minus 5x squared plus 4. Now when you are writing the polynomial here, you can't skip terms. What do I mean by that? Well, this one skips an x term. It goes x power 3, x power 2, there's no x term. You actually have to write it in. So it will actually be 0x in this case. It's really important that you write in this term and don't skip any terms, otherwise you get the wrong answer. Okay. What are we doing when we're doing polynomial long division? Well, we're essentially constructing the polynomial that can be multiplied by this to get this. Now, if you want to multiply a polynomial by this thing here and get a cubic, of course it's going to be a quadratic. The polynomial is going to be something times x squared plus something times x plus something, as all quadratics are. So essentially what we're doing is we're just finding which number goes in each of these boxes. So this is how you do polynomial long division. You go leading term divide leading term. Well, x cubed divided by x is x squared. So we write x squared or 1x squared up here. Now we multiply x squared by x minus 1. Whenever you get a term up here, multiply it by this. So x squared times x minus 1 actually gives me x cubed minus x squared. What have we actually done? Well, we've found when I expand this times this, we won't get x cubed minus 5x. We will get x cubed minus x squared. So I'm actually off. Let's calculate the remainder. We do that by subtracting. So negative 5x squared minus negative x squared, of course, gives negative 4x squared. I'm off by negative 4x squared. So whenever you get a remainder, which I just did here, divide it by the leading term. Negative 4x squared divided by x is negative 4x. So that goes up there. We need this to be a negative 4x so we can compensate for the missing negative 4x squared. Okay. Now what do? Well, I'm actually just going to repeat the process. As I said, whenever you get a negative 4x up there, or any term up here, times it by that. So negative 4x times x is negative 4x squared. Negative 4x times negative 1 is just positive 4x. Now, we want to calculate the remainder. We actually just bring this term down here. It just makes it a little easier to work with. Let's calculate the remainder again by subtracting. So negative 4x squared minus negative 4x squared is just 0. 0 subtract 4x is negative 4x. So that's how much we're missing. If we were to expand this times this, we'd be off by negative 4x. So I need to divide this remainder by the leading term x. So I divide negative 4x by x, I get negative 4. So once again, bring down this term so I can calculate the remainder. And once again, whenever you get a term up here, multiply it by this. So I go negative 4 times x and then negative 4 times negative 1. So here I get this minus this is 0, this minus this is 0. The remainder for the whole division is 0, which of course means x minus 1 is a factor. Now here's a quick way you can check, not that you're fully right, but just that you're on the right track. You can check using the remainder theorem. So when I performed this long division, I got a remainder of 0. Let's check if that's what the remainder theorem tells me. Because the remainder theorem tells me when I divide this polynomial by x minus 1, then the remainder should be f of 1. So if I substitute f of 1 meaning substitute x for 1 into this polynomial, I get 1 minus 5 plus 4, which is 0. the remainder theorem tells me when I divide this polynomial by this, the remainder is 0. Given that that is what I got with the polynomial long division, I can assume that I'm on the right track. All right, that was one method of doing it. Now I'm going to do the exact same question using synthetic division. So synthetic division is essentially the same thing, but a lot of people find it easier because you don't have to write all the x's. So let's do this using synthetic division. So with synthetic division, we're just going to write the coefficients and not write all the x's. So we're just going to write the coefficients of this polynomial here. So the coefficient of x cubed, coefficient of x squared. Now, again, we cannot skip a term. We have to include the coefficient of x is 0, and then the constant term is 4. Now here, we actually write, instead of -1 here, we write the root of this. We actually write +1. Okay, so what do we do here? Well, we bring down this first term, 1. Now we go 1 times 1 is equal to 1, and that goes up here. Now, instead of subtracting to find the remainder like we did in polynomial long division, we actually add here to find the remainder. So we go -5 plus 1 is, of course, -4. Now I start the process again. I take my root, which was 1 here, and I times by -4. 1 times -4 is obviously -4, so I put that there. Now I'm going to add to find the remainder. 0 plus -4 is, of course, -4. So I'm going to follow the process one more time. I'm going to go 1, the root times this one. 1 times -4 is, of course, -4. I add to find the remainder. So 4 plus -4 gives me 0. So these numbers here are our answer. We just have to recognize that when you divide a cubic by a linear polynomial, you get a quadratic. So this first term is going to be the coefficient of x squared. This is going to be the coefficient of x. And this here is the constant term. So essentially, I have found that x cubed minus 5x squared plus 4 divided x minus 1 is equal to 1x squared, or just x squared, minus 4x minus 4. Now, you've probably figured out this final number here, bottom right, is the remainder of the whole division. So in both cases, with long division and synthetic division, I found that if you multiply x minus 1 by this polynomial x squared minus 4x minus 4, if you multiply them together, you will get this one here. I have factorized this polynomial. All right, let's now look at taking it just one step further and solving equations. So let's look at solving this cubic equation here. I'm going to refer to this polynomial as fx, just so you know what I'm talking about. So the goal here is I want to factorize this polynomial. I want to write it as the product of factors so I can then use the null factor law. So factorizing this requires me to find a factor first and then use either polynomial long division or synthetic division. I'll use long division in this example. So to find a factor of this polynomial, we need to find a root. So to find roots, we try positive and negative factors of this constant term here. Now note that the sum of the coefficients is 0. That always means that 1 is a root. F of 1 is just 2 minus 3 minus 2 plus 3, which is 0. That means that x minus 1 is a factor. So how do I find these other factors? Well, I need to use either polynomial long division or synthetic division. So using polynomial long division, I go x minus 1 into f of x, which is this one here. And then we always start by doing leading term divide leading term. So 2x cubed divided by x is 2x squared. So whenever we get a term up here, we multiply it by this 2x squared times x, and then we go 2x squared times negative 1. We now calculate the remainder by subtracting. So negative 3 subtract negative 2 is negative 1, so we get negative 1x squared. Whenever you get a remainder, divide by the leading term. Negative x squared divided by x is negative x. So we'll bring down this one, and then whenever we get a term up here, we need to multiply it by this. So I go negative x times x is negative x squared, and then negative x times negative 1 is positive x. The remainder, negative 2x minus x, is negative 3x. So negative 3x divided by x gives us negative 3. We bring down the 3, and then negative 3 times x, and negative 3 times negative 1. And then when we subtract for the last one, see we get a remainder of 0, which is what we expected because we knew that this was a factor. So what I found is that fx, this polynomial that I started with in black, is equal to x minus 1 multiplied by this polynomial here, 2x squared minus x minus 3. So now what I have to do is factorize this quadratic here. So just in case you've forgotten, we use the AC method. We go a times c is negative 6. Two numbers that multiply to negative 6 and add to negative 1 are, of course, negative 3 and positive 2. So we split up the middle term accordingly. We factorize the first two terms. We factorize the second two terms, and then we factorize again. The common factor is x plus 1, and in the other brackets is 2x minus 3. So that means the other two factors here are x plus 1 and 2x minus 3. So we can now use the null factor law. Either the first thing equals 0, or the second thing equals 0, or the third thing equals 0, in which case add 3 to both sides, divide by 2. These are the three solutions. All right, I'm now going to do this exact question again, but using synthetic division. So I'm going to solve this using synthetic division. As we saw on the previous slide, we know that f of 1 equals 0. 1 is a root, so x minus 1 is a factor. So we're going to divide this polynomial by x minus 1. So remember, when we're doing synthetic division, we just write the coefficients of the polynomial. So 2x cubed minus 3x squared minus 2x plus 3. And we use the root here, which in this case is, again, positive 1. So we always bring down this number here too. Okay, we go. Positive 1 times 2 is 2. So we write it there. Whenever we're calculating the remainder in synthetic division, we add. Negative 3 plus 2, of course, gives negative 1. Then we go 1 times negative 1 is negative 1. We add to find the remainder. So in that case, it's negative 3. Negative 2 plus 1 is negative 3. Last time, we multiply 1 by any number down here. 1 times negative 3 is negative 3, and 3 plus negative 3 gives us a final remainder of 0. We needed to get 0, otherwise we messed up because we knew that 1 was a root and that x minus 1 was a factor. So that tells us that this polynomial here, which I called fx, is going to be equal to x minus 1. I already knew that factor, but multiplied by, this is the coefficient of x squared, coefficient of x, and the constant term. And once again, you can factorize this quadratic here, as I showed you on the previous slide. We got 2x minus 3, x plus 1, and so if that equals 0, either first bracket equals 0, second bracket equals 0, or third bracket equals 0, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.